In this video, we are going to learn how to use our route map statements. Route map statements are more sophisticated. It's more like a scripting language when compared with our previous filtering methods, like we use prefix list, distribution list, and also we have seen some pass interfaces, offset list. So it's more better than that. So why it is better than? Because it's more like a program where we use if-else statements, like if the condition matches, do this, and if else, or we can say else if the condition do not match, then we can define a second condition, and based on that second condition, if that second condition matches, then it is going to say, okay, do this. And if the second condition also do not match, we can define a third condition, and based on that third condition, again it is going to match the networks and do this. If that condition also doesn't match, we can define the fourth condition, fifth condition. That is how it is going to work, more like your if-else statements. Okay, so let us take one example here. I'll come to all these points which we discussed here, but I got a simple example. Same example I'll be using in my lab, which we'll be discussing in our next video. So let's take an example. I got an OSPF domain, which we'll see in our next videos, and then I'm going to have some RIP routes which are coming from here. And what I'm going to do is I'm going to redistribute these RIP routes into OSPF. I got a simple scenario here which is going to explain. So I'm going to redistribute 4 routes or more than 4 routes. In that, the 2 routes should get some different value and remaining routes should get different value. So when I'm doing redistribution, by default we define something called metric and metric type. I want to have different parameters for different things. So this is something what we cannot do in my use distribution list or the previous methods, pass interfaces. So I'm going to use route maps here. So the first thing we need to define an ACL here. So the first step, when you're using a route map statement, the first step will be always you have to match the specific networks. Now to match the specific networks, either you can use ACL, which is the most common way, the most familiar way of doing the things, or we can even use a prefix list statement, which is going to match a specific source address with respect to slash value. Now it's up to you which statement you want to use. So to match the networks, again we are going to use ACL or prefix statement, but we are not using any distribution list here. So even the distribution list also will do the same thing. They use either an ACL or they use a prefix list statements to define the networks. Now after that, I'm going to define a condition here. I'm going to create a name. Route maps will be given a name, specific name with a name called CCNP, and then we'll say define called permit 10. So this number is going to define the sequence. Okay, so when I'm saying 10, 20, 30 means it's going to define the first statement, second statement, third statement, fourth statement, like this. So it's more like an if not matches, this is just like an else if, and again finally else. So I got 3 set of statements here. So this sequence number are going to define which statement should be filtered or which statement should be checked first. And majorly inside that, again we have something called match, 2 major commands which we use inside that match, and we are going to use something called set. Okay, so match means match specific networks. These networks we have to define here, and set, in the set of we can define set metric or metric type and various BGP parameters. Now it depends upon the requirement. So majorly we use these 2 parameters, where in the first statement we are going to match, in the next statement we are going to set the respective parameters here. Okay, so we'll get into this particular statements here. Now first it will try to match the statements. If it does not match, it will try to match the second condition. If the second condition also do not match, in that case it will finally go with the last condition here. If the last condition also do not match, then those particular routes will not be used, or it's just like a permit any. You have to make sure that all the remaining routes should get matched. Okay, so let me just quickly go down to my basic slide here. You can see route maps, they work like a more sophisticated access list. They work from top to down, like permit number, sequence numbers we used, and once there is a match, it is going to leave the route map statement, which means if the first statement match, it is not going to check the third, fourth or fifth statements. So just like in normal ACL statements, but the only difference is in ACL we are going to define a specific specific networks where we match, but in case of route maps we are going to define some conditions what to do with them. Okay, so line are the sequence numbers for easy reading, like we use a sequence number of 10, 20, 30 here. If you try to see here, I use permit 10, permit 20, permit 30 statements for easily editing. So if you want to add any line in between, you can create one more route map statement with CCNP, and I can say permit 15. So it will automatically come in between that. That's for easier editing. Insertion of the lines, deletion of the lines. We can edit the lines, we can easily delete the lines as well. And here we use names instead of numbers. So the route map name will be always, route map will be identified with some respective names, so no numbers here. And finally, match criteria and set criteria can be used similar to your if then logic in our scripting language. Okay, so in short, we'll see more in detail a practical configuration part. So route maps are very much commonly used in the production networks. They are more better way of filtering the routes, because the route maps can be used at the time of redistribution. So the more sophisticated alternative your distribution list. So we'll see some labs also where we'll try to deny some specific routes in a more better fashion based on the conditions. So we got a small labs coming up where we'll be using a distribution, where we'll be using a route maps instead of using a prefix list statements here. So how we can use that, I'll come up with a short video on one specific lab, this one. And we have a separate video on policy based routing, which is one of the common implementation we call as PBR, policy based routing, where we can define, where we can match some specific networks. Like take an example, you got 10 dot network and 20 dot network, and you want to make sure that this 10 dot network should use the first route to the internet, and I'm connecting to two ISPs, and I want to make sure that the 20 dot network should use the second next. So we can define match these networks, and we can set the next hop address this, and match these networks, and we can set the next hop address this. So this is something we need to do. We call this as policy based routing. We'll see in a separate video on that. For that also we are going to use our route maps, and most commonly with BGP implementation, because when we get into BGP topics we have some route filtering over there as well, where a service provider, where we want to make sure that only some of the routes should use this route, or the alternate route should use this route. If matches, use this route. If not matches, use this route, like that. We got some specific conditions where in BGP also the route map will be the main tool for defining the different route policies inside the BGP. Okay, so we'll be getting into our lab in our next video. So I hope you got the topic, got the content here. So we'll practically verify this scenario in our labs in our next video. Thank you.